So if we have V and W be some finitely generated vector spaces, so and finitely generated, then we can find and we have some linear map. We can call it F between these two vector spaces, and we also have basis of V is going to be some so this basis of V, we can call it, for example, B1. It will contain, for example, these vectors ranging from V1 until Vn, and basis, so the minimal generating set for V, and basis of C, basis of V, we for example B2, but we don't even have to know what is B2 necessarily here. Then we can actually create this equation that says that the matrix of the linear map can be also created specifically in context of these bases. So they don't have to be the canonical bases like E1 till En, 1, 0, 0, 0, 1, 0, and so on. They can be other more complicated bases, as long as, of course, they're a linearly independent set and so on. And so we denote it like this. Well, we have a different notation here. We namely have B1 and B2, and it's equal to the matrix created by basically taking F of B1 and expressing it in the basis B2, and doing this until, of course, F of Vn, and expressing it in the B2. And this whole base matrix gives us the linear mapping in respect to the two bases. So the default linear mapping would be between the canonical ones, but we can do it between specific bases. So this is a formula for it. It works well. An example of it could be, let's say we have the mapping f of xy goes to x plus 2y and 2x plus y, which is also expressible as 1, 2, 2, 1 in the default basis. All right, so this is simply basically K2, K2. But what if we want something different? What if B1 is 1, 1 and 1, 2? In such case, these are of course linearly independent, so it works out, spans spans R2 if this is over reals. And so this is B1, and B2 would be, for example, 2, 2, 3, 2. Then, so this is a separate example. Then what we have to take this formula and use it. So B1 and B2. So we will get F of the first vector of the first basis of 1, 1, expressed furthermore in B2 and until the vector f of 1, 2 expressed in B2 again. And actually we only have two vectors here, so this is a concrete example, so it's just these two and that's it. So that's what we need, and the f of 1, 1 is this. So we multiply it first, the 1, 1 by the matrix from the left, and then we express that result in B2.